Alrighty, more dominoes. Feel like it should be something related to wars or stars for today, but it isn't. Okay, you have two types of dominoes, or two types of shapes, 2x1 domino and a Tromino. You may rotate these shapes. Okay. You're given an integer n, return the number of ways to tile 2x n board. This answer may be large. Okay, so n can be up to 1,000. Okay. This is just a mathematical thing, really. I don't like you could come up with the way to maybe represent these graphically, but like uh see like there's just a formula here, and if you use the formula it's probably gonna be like maybe there's an algorithm. I don't know. Alright, so the number of ways to tile 2x1. Interesting. I recall doing some other exercises where I got stuck on something like this pretty badly. Yeah, I recall something that I got stuck really badly. Okay, how to do this. So if it's the number of ways you can tile a n by a 2x n. Oh, it's a 2x n. It's not even like an n by n. Okay, well that's really, really simple then, I think. Well, you don't want to use recursion here because recursion is going to be like if you recurse back to n equals 1 from when n is 1,000, like the call stack will be just too, there's just too many recursive calls. So it has to be an iterative approach, but the iterative approach will use some kind of recursive values. So for let's see. So how would it recurse? So if you had, okay, so let's say it's n is 1, then there's one way, right? It's just a single upwards domino. If n is 2, then there is going to be a 2x2, and there's going to be either 2 upwards or 2 sideways, so there's 2 ways. If n is 3, it's a 2x3, and that should be 5 ways, like in this example. So what is the relationship between n is some number and like n is 1 less than that or 1 more than that, right? So from 2 to 3, you have one additional way where you have a vertical, right? So like this is one of the 2 ways for n is 2, and this is one of the 2 ways for n is 2. So for each of those ways, you could add a vertical. So it's the same. So it's the previous way, which is 2, and then there's 3 more. So 3 more coming from if you go back, if you go back, if you remove one of the verticals and make it one of the last verticals and make it 2 horizontal, or you remove both verticals and make it a 2 versions of the Tromino. So this is 5, which is equal to the previous ways plus a vertical domino. Vertical Domino. So that gives you 2. And then 3 other ways, which is going to be the number of ways for n minus 1. So actually n minus 2. So this is the previous ways as in, this is the count for n minus 1, and this is the count for n minus 2. Because if you have that number of n minus 2, you can add 2 verticals, plus or 2 horizontal. So that gives another way, and then the count for n minus, no, that's actually, the previous ways is n minus 1, and this is n minus 2. Actually, if n is 0, there's 0 ways. Okay. And the count for n minus 3 plus times 2, no, plus 2. So there's 1 way to do 0 actually. Okay, that's how that works. So the count for plus 2 Tromino. Okay, so I think it's going to be like if I have f of n is equal to f of n minus 1 plus f of n minus 2 plus f minus 1 f minus plus f minus 3 times 2. Okay, I think that's the relationship. So here I'll have my counts, and it's going to be starting 1, 1, 2, and then for size in range n, where size starts with, this is going to be 3 to n, counts.append total for this thing is going to be counts at -1 plus counts at -2, negative being from the last, so -1 would be 2, counts at -2 would be 1, and then 2 times counts at -3, and then append that to the total, counts.append the total, and then return counts at n. Okay, so just going through a single pass here. If n is 3, then this does it 0 times. So it should be n plus 1 here. So if n is 3, it does this once, and then it gets 5, appends 5, and then returns counts at 5. Okay, counts at 3. I think that's right. Alright, that's wrong. Excellent, excellent. So it's right for n is 3, I think. Let's do this. So n is 4 should be 9. No, it should be 11, but my answer is 9. Okay, so let's do n is 4. Actually, was this one of the examples? Nope. So should it not be you take the previous number of ways for n is 4, you add a vertical bar. Okay, that seems fine. So that should give you 5. 5 from n minus 1. And then if you take it from n minus 2, you can either add a 2 horizontal if you take it from n minus 2, you can add two horizontal bars. So there's one way for that. So, and for here, that should be 2 ways from 2 from n minus 2. So my tests, so the answer should be just 9. So 5 plus 2 is 9. And then you do 2 times n minus 3. 2 times n minus 3 should be 2. What did I do wrong there? N minus 1, n minus 2, 2 times n minus 3. Okay, let me go ahead and print my counts at this point. What's going on? So it should be 5 plus, no, actually okay, I'm confusing it. The output should be 11. Okay, so what am I missing? So you add 1 vertical, number of ways you do the previous n minus 1 plus a vertical, the number of ways you do the previous n minus 2, and then you can't do 2 verticals because that's already counted, so you have to do 2 horizontals. And then the number of ways you do n minus 3. N minus 3, and then you have 2 Tromino. So that thing times 2. There's actually 11 different orientations here. What are the orientations that I'm missing? So I've had a vertical. If I add a vertical to n minus 1, add 2 horizontal. Is it possible that it goes deep like that? So I'm missing 2. I'm missing 2. So n minus 1 plus a vertical. That should be 5 ways. N minus 2 plus 2 horizontals. And then n minus 3. Is there some other configuration here? Oh. Ah. Oh, it's something like I don't know if I can so it could be like a Tromino T shape here, and then like a domino, a horizontal domino here, and maybe another Tromino T shape here. Okay, I see. But then there's only so many configurations of that, no? Well, maybe there isn't. So it could be either that or it could be something like this. So there's an extra two ways there. Is there any other weird shapes that I'm missing? So it's like n minus, oh boy. So it's like n minus 4. N minus 4 times 2. Yeah. Okay, so it's going to be n minus 4. Jesus. So there's one way of doing n minus 4. So 3, I think this still works. N minus 4 times 2. But it doesn't work if it's... actually, it should be 0 here. Yeah, okay. Plus 2 times counts at n minus 4. No, that doesn't work. Actually, it went down. Oh, yeah, it should be counts at n plus 1 now. Less confident every time. Yep. Now it's wrong on the next count. Okay, okay. What is going on? So again, it's off by 2. So if you have a 5, is there some other ways of doing 5? So if you had a 5, is there some weird shapes? Yeah, it's something like this maybe. Yeah, yep. Or it could be... Yeah, it could be something like that. So is this just like 2 other ways of doing weird stuff like that? Or is there other weird stuff? Yeah, because if you have a vertical bar, then it's always going to be counted within one of the previous n minus whatever, so it has to extend out. And it always has to be this weird shape, so it should be 2 times anything, 2 times the number of things that are like past n minus 2 times the number of things that are past. Oof. 2 times the number of ways for each count from n to something smaller. Okay, so I think I need a sum, like a mini sum thing. gonna be a mini something. Yeah. Maybe I'll call it prefix sum. Prefix sum is gonna be starting at, let's go back to 112. Actually, should I go back to 112? Should I go back to 1, 2? 112 is fine, I think. So 1 is for 0, prefix sum is going to be 1, and this is the sum of like the everything before the last 2. So this is just going to be 1. Okay, so it's going to be counts of the previous 2 plus 2 times the last prefix sum, and then the prefix sum should add on to it. Prefix sum dot append counts at -2. And here this should go back to doing counts at n. Not quite, not quite. Two times prefix. So let me go ahead and print out the prefix and the counts. So it's going to be prefix is 1. Oh no, what am I doing? Prefix appends the last prefix sum plus counts at -2. Yeah. What am I doing indeed? Okay, let's see if that works. Oh, I need to do mod. It's too big. It's too big. Total is modded by the mod constant. And let's do head. Okay, sure. Slow. You say I'm slow. I'll agree that this might be slow. Is it all that slow? I mean, okay, let me go ahead and do something that is, let's do the test case. Okay, let's go ahead and do print the counts. And I'm gonna do it for n is, let's say, 10. Sometimes it's a little hacky, but if you just include a little more of the because the way that this works is it's going to recalculate this for every value of n, where n is up to 1000, right? So in theory, you could actually just like hard code your answer here. But if you just hard code a little bit, then that means it doesn't compute these initial ones like a bunch of times, because like obviously if you have a bunch of random numbers between 1 and 1,000, it's all going to do like 0 to 10 a bunch of times. So I can do this, and I can say the range is now, instead of 3, so 4, 5, 6, 7, 8, 9, 10, 11. So 3 was the original number. So I think it should make sense that the number of numbers here would be the smallest here. 0. So 1, 2, 3, 4, 5, 6, 8, 9, 10, 11. So I don't think I need to compute anything lower than 11. Yeah. Okay, let's see if this hard coding hacks the results or the speed. It doesn't even get it right. What the heck? Oh, yeah, I I need to get the prefix sum correctly, actually. The prefix is now no longer just the first one. I need to print out, ooh. Okay. Let me think how to do this. Let me go back to my previous version. And print the counts and the prefix. Okay, so I'm going to use this set for my counts. I'm going to use this set for my prefix. Hopefully it's going to be smaller. Good. I'm going to say this is 11. Let's try a test case where it's a 20. Okay. Think. Bam. Hacked indeed. Yeah, in theory you can just like print out the first 1,000 in your thing and just hard code it. Okay. But I'm not gonna go that far. So okay, so what's the deal here? Summary. So there's going to be, this is kind of like a math problem, deal. So it's the number of ways to form 2 by n depends on some depends on adding some combination of Domino / Tromino to previous 2 by p, where p is value less than n. So if you have, so in general it's going to be the function for n, where n is the count. Let f of n be count for ways to form with 2 by n. So it's going to equal f of n minus 1, the number of ways that you form 2 by n minus 1, plus a vertical. So that's just one way of doing that, or one multiplier doing that. plus f of n minus 2. So you form, so if it's n is 3, then you form n minus 1 plus the vertical, or n minus 2 plus 2 horizontal. So one way of doing that. Plus 2 times 2 times f of it's not 2 times f of n minus 3, although you can think of it for the case of where n is 3. The case of n minus 3 is n is 0, and there's one way of doing that, and you can add 2 Trominos to the n equals 0. But it's more like 2 times f of the sum of f sum of f from the sum of f of k, where k is less than n minus, where k is between 0 and n minus 3. So the reason why this is because if you had something that was like n is 4, then not only will you have like these deals, so for each count where k is n minus 3 and smaller, you can have some version of that where you have like it could be the Trominos are arranged into L shapes like this, that's n minus 3 away, or the Trominos can be arranged into kind of L shapes like these, that's 4 away, and then they can be arranged into things that are L shapes at the end, and that's 5 away. So like this, and that. Yeah. So anyways, it's for everything that's before, that's less than n minus 3 away, it's 2 times that. So that's why I have this prefix sum. This sum is going to sum up the things that are the counts that are 2 away from the current. So let's say we're dealing with n equals 3, then the sum is just 1. If you're doing this one, the sum is going to be 1, 1, which is 2. And the next number is 2, so the sum of these first things is 4. So anyways, that's necessary for you to do this count. Alright. So basically use use an array for the counts and access the last elements in the array to do the iterative calculation rather than using recursive calls, as the call stack would be too large when n goes to 1,000, and also use a prefix sum array for the for part of the calculation. And then lastly, can hack the speed of the algorithm by storing more kind of starting values or solved counts for low n values. So rather than starting with just like 1, 1, 2 as 1 being the number of ways to do 0 dominoes, 1 being the more ways to do, or n equals 1, or n equals 0, n equals 1, n equals 2. Rather than just having that and starting the iterative process with a small array, if you have just a larger number of kind of base cases, then your calculation, which is always just going to start when n is small, all the way up to n is large, there's going to be less calculation, just more fixed, just answers. Will make it faster compared to other solutions. Now technically you can store all 1000 values and return the answers there. So time complexity is going to be O of n basically for the honest solution. But if you store answers, it can be just O1. So I mean, in theory, because there's actually no variation in n, you know all the range of values for n is kind of finite. You could just store all the answers. From a fixed array of solutions. And then space complexity, this is going to be O of n for the array